Welcome to this video. In the previous video, we learned about similarity, similar triangles, and basic proportionality theorem. In this video, we will learn the angle-angle-angle or AAA criteria for similarity of triangles. When do we say that the given two triangles, ABC and PQR, are similar? In the previous video, we saw that two triangles are said to be similar when their corresponding angles are equal and their corresponding sides are proportional. Now, a question that arises is that for testing the similarity of triangles, should we always have to check if the pairs of corresponding angles are the same and the ratio of their corresponding sides are also the same? Let's take the help of some equiangular triangles. Can you tell which of these triangles would be equiangular triangles? Absolutely correct. The triangles whose corresponding angles are equal are called equiangular triangles. Let the value of the corresponding angles of all triangles be 80, 60, and 40 degrees respectively. If we notice triangles ABC and PQR, we see that their corresponding sides AB and PQ, or BC and QR, and CA and RP are all in the ratio of 1/2. Now, if we observe the triangle ABC and XYZ, then we see that their corresponding sides are proportional. Can you tell the ratio of the corresponding sides of triangles MNO and PQR? If we look at these two triangles, MNO and PQR, then we see that the ratio of the corresponding sides is 3/2. In this way, if we take any two similar triangles, then we see that their corresponding sides are proportional. This activity teaches us about similarity of two triangles. This activity leads us to the conclusion that if in any two triangles, if the corresponding angles are equal, then their corresponding sides are in the same proportion or ratio, and hence the two triangles are similar. This criteria of similarity of triangles is called the AAA criteria. Here, we can say that equiangular triangles are similar. In this video, we studied about the AAA criteria for similarity of triangles. In the next video, we will look at some interesting examples based on this theorem. Welcome to this video. In the previous video, we learned about the AAA criteria for determining similarity of triangles. Today, in this video, we will look at some interesting examples based on it. In the given figure, show that triangles XYZ and DEF are similar to each other. What can you say by looking at the figure? You can see in the figure that the corresponding angles, angle ZXY and FDE, and angles YZX and EFD are equal. Can we prove the similarity of triangles with the help of these two angles? No. For doing this, we need to know the third angle or the corresponding sides of the triangle. Can we find any other measurement of this triangle? In the given figure, it's difficult to determine the length of the sides. But we can find the measurement of the third angle. Can you tell how? We know that the sum of all the internal angles of a triangle is equal to 180 degrees. With the help of this, we can find the measurement of the third angle. Here, we see that the corresponding angles of the triangle XYZ and DEF are equal. That is, by AAA criteria, triangles XYZ and DEF are similar. Can we solve this by any other method? If we observe this example, then we'll see that in two triangles, if any two corresponding angles are the same, then their third corresponding angle would also be the same. Hence, we can conclude that two triangles are similar if they have two corresponding angles that are congruent or equal in measure. We call this the AA criteria for similarity of triangles. We can test this with the help of any other pair of triangles. In today's video, we looked at an example based on the AAA criteria of similarity of triangles and also studied the AA criteria. Welcome to this video. In the previous video, we studied the AAA and the AA criteria. In this video, we will look at another example based on it. In the given figure, triangles FEC and GDB are congruent and angles 1 and 2 are similar. Show that triangles ADE and ABC are similar triangles. From the question, we know that triangles FEC and GDB are congruent and angles 1 and 2 are equal. Because triangles FEC and GDB are congruent, we know that corresponding sides of congruent triangles are equal, by which we get equation 1. Now if we look at the triangle ADE, we get to know that angles 1 and 2 are the same. You would remember that the sides opposite to the equal angles in a triangle are also equal. Hence, sides AD and AE would be equal. If we find the ratio of equations 1 and 2, then we get equation 3. Equation 3 tells us that the line DE divides the sides AB and AC of triangle ABC into equal ratios. What do you understand from this? According to the inverse of the basic proportionality theorem, we can say that the lines DE and BC are parallel lines, because of which angle 1 is equal to angle 3 and angle 2 is equal to angle 4. Can you tell why? As we know that the angles corresponding to the parallel sides are equal, because of which in triangles ADE and ABC, angles 1 and angle 3 and angles 2 and angle 4 are equal. Hence, by the AA criteria, triangles ADE and ABC become similar. This is what we had to prove. In this video, we saw how to determine if triangles are similar by using the basic proportionality theorem and the AA criteria. I hope that you have understood the AA criteria well.